Assalamu alaikum. This is our semester project of MES, a line following robot. Uh, the proposal of this project was that we have to design a robot that will detect a line and would detect obstacles coming in front of it. On detection of an obstacle, the robot must move back to the starting point by using the path stored in an SD card. All of the decision that is took by the robot would be stored in a SD card. Then there would be a current and a voltage sensor that would be connected to the battery, and it would display the current and voltage levels of the batteries and the robot. These current and voltage would be displayed on an LCD placed on the robot. The speed of the robot is also displayed on the LCD. Also, on detection of an obstacle, the color of the obstacle is displayed on the LCD. Every data that has been detected by the sensor would be displayed on the LCD. The initial feasibility of this project was divided into two parts. Uh, First part was to understand the basic programming of a turtle robot in Proteus, and the second part was the prototype. The prototype was made with uh, 3 IR sensor, 2 motors, and a L29 3D motor driver. The specification of the deliverables was as follow. Uh, we have these the every work every task was divided into the team members accordingly. uh, we have four members in this group. Every member has its own uh, tasks. uh, my name is Haider Sajad, and my task was sensor interfacing and programming every module and sensors individually. This is the structure graph of the project. uh, we have this Gantt chart presented here. The estimated budget. The estimated budget was 10,000. The basic introduction of the robot was it is basically a line follower robot. Uh, it is also a obstacle avoiding robot. It also detects colors, and it can present all of the data that has been sensed by the sensors on the LCD that has been placed on the top of the robot. And we have some current values, some voltages value, some speed values, and some we have also color values that has been detected by color sensors. And these all of these values are wirelessly transmitted to any Bluetooth module using the Bluetooth module. These are the list of features and operational specification of our projects. Features are 3 IR sensors are used to detect black lines with great precision, and thus on the angles on paths such as 90 tons and 45 tons are also covered. Project is also capable of avoiding any obstacle as ultrasonic sensor is used. We have also implemented the speed monitoring system by using a tachometer. We have used two motor for two wheels mounted. We have used an SD card to store the path the robot follows. We have also used an LCD panel helps to display that will help to display the input voltage and current, speed of the color of the obstacle. Also, input and voltage and current, speed of motors, and color of the obstacle is wirelessly transmitted to any Bluetooth device using Bluetooth module. The operation. The passive operation of line follower are as follows. It follows a black line on detection of obstacle. Robot stop. Mm, Color of obstacle should be detected. It should store it in path. It should store the path in the SD card, and detection of obstacle by using path stored in SD card, and robot should move back to its starting position. Project development process is as follows. After the detailed literature survey through the books, websites, and documents provided, the idea of the project is well defined. The logic is derived from the intelligence of the robot, and then we have also the accuracy and viability of the program checked, and researched by from some websites and books, and then tested in the simulation afterward using portraits. After the successful simulation result, it is implemented in the hardware. From the hardware, we have designed our PCB and kept moving in the forward direction and adding new things in the project. After finishing the programming, electrical electronics parts, the stable, reliable, and flexible mechanical designs and fabrication is completed. Finally, the system is tested and an encountered error is omitted. This is the basic block diagram of the whole systems and subcomponents. Uh, we have, as a whole, uh, excluding these two micro controllers, we have 16 components used in this whole projects here. Uh, we have a complete specification of individual uh, component: ultrasonic sensor, a sensor that detects obstacles in front of placed in front of the sensor. This is its pin configuration. Then we have an Atmega 328P chip. It's a microcontroller chip from the Atmel AVR family. It is widely used in various embedded system and projects due to its versatility and ease of use. These are the basic introduction of Atmega 328P, the memory, the clock speed, the peripherals, analog to digital converters and its programming, Arduino compatibility. This is the pin configuration. We have the IR sensor. Then IR sensor is also a sensor which detects obstacles and lines or colors. The obstacle avoiding sensor uses sound, and IR sensor uses lights to detect things. We have then an L293D motor driver. A motor driver is a must in a robot because it would control the speed and direction of the robot, the motors. Then we have a 20 gear motor. These are the specification, the features. Then we have an encoder. Encoders. The N20 gear motor don't have any compatible rotating disc that can be used as inference. A reference like the disc used for TT motors. To measure the RPM of the motor, we use a technique called tachometer. SID card module, a module that is used to read data from the card and store data in the card. This was used so the all the decision taken by the robot should be stored in the memory card to be used in the future. And we have used a 16 multiply 2 LCD display with I2C module. These are the pins configuration of the LCD. This is I2C module pin configuration, and this is we have also used a current sensor, a voltage sensor, a color sensor, a Bluetooth module. Let's come to the mechanical design. Mechanical design. This is the mechanical design that we have designed ourselves in the AutoCAD or SolidWorks. Then it was converted into a hardware design. This is the CAD design, and then we have electronic design and sensor selections. Then we have gone through the selection of components. These are the components that have been used in the whole project. These are the specifications of the sensors and components from data sheets, same as above. And 20 gear motor, L293D, IR sensor, ultrasonic sensor, 60 multiplied by 2, LCD, I2C module, a voltage sensor, a current sensor, a color sensor, Bluetooth module. And then we have the power requirements and power supply design for it as well. The power requirement for the system is specified as 5 volts and 12 volts, and the electronic voltage is crucial parameter that signifies the electric potential difference. Then we have used then we have selected motor selection, current, voltage, speed, torque. We have selected everything, each and everything. The maximum current that would draw is 0.70 amperes. The maximum voltage would be 12 volts. maximum speed rotation is 320 rotations per minute. Maximum torque is 27 kgmm. These are the deliverables of complete electronics design. This is our circuit schematic, and this is our PCB design. It is a two-sided PCB, top, bottom, and bottom and top. Mm, uh, Chapter 5 is about software firmware design. Controller selections with features. We have selected a 328p. Then we have the parametrics of the chip. The advantages, disadvantages also mentioned in the report, and the components that are used in this software design are as follow. These are the inputs, the outputs, the communication modules. This is our state machine and system flow diagram. Uh, this is our detailed block diagram. This is our truth table for the project. These are our simulations and final integration, the codes and everything from the final stages. uh, Integrations and testing of all hardware and software components are separately done. At start we have coded 3 IR sensors and a motor driver individually. Here in this code we can see sensors of the three sensors are defined. Here we have the motor drivers, pins defined, enablers, enable A, enable B, and 4 inputs. And we have defined a speed of 150 in the code. Then we have in the forward function, all the motors are off or all the inputs are off, just the input 1 and input 4 are high. In the left we have input 1 high and input 3 high. In the right one we have low input 2 and 3 high, input 2 and input 4 high, and stop we have all the inputs at low, so the robot is stopped. This is our setup. The wide loop, if the left sensor detects, then it would go forward, and if the right one detect, it would go right. If the left one go sorry, that first one is not the left one, it is the middle one. And then whichever sensors detect to the right, it would go to the right, the left it would go to the left, to the middle it would go to the forward. And if no sensor detects anything, the robot is stopped. This is our schematics of the robot. uh, this is our ultrasonic sensors code. Trigger pin and ego pin connected to the A2 and A3 pin. We have a setup. In setup we have two pins that are considered, one is considered an output, one is considered an input. We have initiated the trigger pin here. This is the whole code is this is here used. So the we have a duration variable, we have a distance variable that is being calculated. Then we have a if statement. If the distance is less than greater than 400 or less than 2, then it will say out of range. This is our SD card module, the code for it. This is the schematic of the SD card. These are the voltage sensor code, the current sensor code. This is color sensor and Bluetooth module code as a whole. This is the schematic of the color sensor. This is the Bluetooth module schematics. I2C display module code. The schematics, the encoder's tachometer code. This is a compiled Arduino code driver controller code. This is all the code of everything combined. Senses reading controller at Mega 328P. We have used two microcontrollers here. One is for robot control and the other is for the sensor data. This is the sensor data controller. We have two codes as a whole written in this whole project. One is for sensors and one is for robot control. And then we have a simulation schematic here. PCB simulation. This is the top copper of the PCB. This is the final testing. Now we have arrived at our final stage, the system test phase. Final testing, first stage, the PCB was checked and fabricated. The second stage, everything was mounted successfully on the PCB. Third stage was integration of module and coding and calibration and everything. Things that are questionable and got burned again and again. If somehow the direct 12 volt is supplied to my controller, then they will be burnt. As also, if input voltage is greater than 14 volts, that the motor drive will be burnt. The accuracy of the color sensor and control of speed uses the motor driver is questionable. The height of the IR sensor plays an important role in the accuracy of ultrasonic sensor. These are the project's picture, the actual project pictures. This is my turn on the sensor interfacing. How did I do the sensor interfacing of each and every sensor? Comments about success and failure of our project, the bill of the project, and the risk management that we have learned in this project is that it is the main risk management that we have learned was in PCB manufacturing. PCB etching was a bigger risk that we have encountered, and we have solved this issue, and the issues the issue is that in order to avoid the issue was that somehow after the etching the lines are disconnected or erased, so we have to do this process very carefully. My feedback on the project and course, you will find the YouTube link here at this point and the GitHub link at this point.